Good afternoon, everyone, and welcome to another live Quanser user webinar. In these webinar series, we highlight the work of academics around the world that use Quanser solutions and technologies. My name is Michel Levy, and together with my colleague Gemma Wang, we will be your hosts and moderators this morning. Today, we're very excited to have a great friend of ours, Dr. Eric Hamke from the University of New Mexico. Dr. Hamke received his PhD in electrical engineering from the University of New Mexico in 2020, and he's worked in major companies around the world, right in the States. Throughout his career, Dr. Hamke worked in the field of new digital communication systems and the development of avionic devices to include flight control, navigation, and camera pointing systems for drones. He's currently a lecturer at the EC department at the University of New Mexico, and a mentor for the innovative Y Lab, which will be discussed today. And on that note, I would like to hand it off to Dr. Hamke, and please, everybody, enjoy the webinar.
Well, good afternoon. Sounds like I had a really good introduction there. Thank you very much. Today I'm going to talk to you about the Y Lab and how we empower creativity and curiosity in students. As I found when I was working in industry, it's kind of funny, but that's what they pay you for. It's not the formulas and the knowledge, it's how you apply it. So this is one of the things we like to do with the Y Lab. I'm not going to spend much time on an introduction. I think that was rather well handled for me. So basically, I've been working different corporations during my 30 years. I started out as a PhD student here at UNM. As I was doing that, they hired me as a lecturer because of my work experience. And then I wound up putting together the Y Lab. And I'm kind of what they call a proctor mentor for the lab. And I'll explain a little bit more about what that involves and what's going on there as we get into the presentation. So why do we have a Y Lab? And where did the acronym Y come from? And this is, I got introduced to Tom Lee and Dr. Jordan, or Dr. Ramiro Jordan here at UNM. And they were talking about trying to figure out how to address a problem that we're seeing a lot in the freshmen coming into an engineering program these days. A lot of people pick electrical engineering because, well, they like the paycheck, but they're not quite sure what electrical engineering really is. So part of what we started talking about doing was putting together an introductory class to electrical engineering, where we would do it through a series of experiential options or opportunities and allow the students to kind of get some firsthand experience with what it is that they're going to be getting into when they start working in the program, with the idea that maybe we can increase retention because the students understand what it is that they're getting into. So part of this was, what do engineers do? How do they do it? And the biggest problem that I see with a lot of the freshmen and most of the time with most of the students I work with is a lot of students are sitting there scratching their head wondering, why am I taking this class? So part of what we do in the introductory class is I basically introduce topics and ideas, and then I proceed to walk them through which pieces of the curriculum or what pieces of the courses they're taking in the future will they come across the information that we're talking about in the 101 class. The basic idea was that we were going to use a QBot, and we were going to sit down and use the QBot to do a series of experiments that will allow students to get familiar with all the different aspects of electrical engineering in the department. We have people that do power and energy, we have communications and RF systems or antenna design going on in the department. We do controls and robotics. We have a group of people that actually go out and design semiconductors and microprocessors. We have people that do computer engineering. We have a rather strong software engineering program here. And we do signals and systems and image processing and digital signal processing. So the idea was to sit down and use the robots to kind of highlight the different aspects of the program and get students involved in working with those aspects. As time went on, people began to realize that, hey, Eric is sitting here in the lab. And when he's not teaching one-on-one classes, there are other things that he could be doing. And so the process of what the mission or the focus of the lab changed a little, to include things like the capstone program. We have a 2-semester course that the students take in their senior year, where basically we try to give them a real world problem and let them sit down and solve it, and without us telling them how to do it. And so we work with that. The other thing is we wound up having an initiative on campus trying to recruit undergraduates into doing research. So part of what I do here in the lab is I help people discover if they have a research interest. One of the things that I find is that research is a very personal thing. It's something that you do all the time. It's not something that you do for a semester and when it's over with, you go on to another topic. So I try to sit down with the students and help them discover what it is they're interested in. Some of the bullets here on my slide are things like learning how to use the information that they're learning in class outside of class. In other words, this is not just something that you use for homework problems or getting through a test. Part of it is that in the engineering programs, we have a lot of emphasis on learning how to do things in a certain manner or a certain way, because that's how you solve this kind of a problem. And sometimes the kids have no outlet for their creativity. So try to provide some space in here to let people be creative. In other words, if someone sees something in class that kind of triggers an idea, then I welcome them to come into the lab and we'll work on making their idea into something maybe that is real. The other thing I see that's kind of funny is that all the students know how to do the math and they all know how to get the numbers, but sometimes they don't quite understand the numbers that they're coming up with. And my favorite example of that is I was working with a student who solved a physics problem and he came up with a speed of 10,000 feet per second, and it didn't occur to him that that was pretty close to Mach 10. And as soon as I pointed that out to him, it's like, oh yeah, that's really a bad answer, isn't it? So anyways, the other thing that we're doing is that the lab is beginning to grow a little bit more. We're getting involved in a process or an activity called peace engineering, which is basically looking at how to use engineering technology to solve some of the problems that we're facing with climate change and some of the other issues that are going on in the world in general. So this is the Y Lab. I have, you can see in the middle is my drone flight space. That's my 15 by 15 by 9 foot cage for the drones. Over there on the right-hand side, you can see the computer lab that I've set up so students can come in and work. I have all the department software on the thing so they can come in and work in the lab and get used to being in here. And they can work on their projects. I also have facilities for fabrication like 3D printers. And I don't have it here in this particular set of pictures, but I also have a electronics workbench where they can come in. It's a soldering station that allows them to do both surface mount and through hole. And I have things like oscilloscopes and function generators and power supplies, so they can build circuits and test them down here as well. So what are the principal concepts of the lab? Well, one of the things is that this lab is student-centered. And what I mean by that is that I don't have a research grant where I'm being driven to go out and do research and provide results to the people who gave me the grant. In other words, the research that we do in the lab is all focused on what the students are interested in. So part of my job here is to be a sponsor of projects. In other words, students will come to me with an idea and we get into it, and sometimes I have students that come into the lab who want to be part of the lab but don't have an idea of their own. So I keep track of all of this, and when possible, I organize a team. So I'll put the person who has an idea in charge of the team, and then I'll get 2 or 3 people to come in and work with him or her and get the project going. Part of my job is to provide equipment and materials. On good terms with a lot of people in the department, so I can go and borrow equipment for the students. And if I can't borrow it, I have a small department budget where I can actually go out and buy stuff to support projects. The other thing I do is provide a little bit of project management. So I sit there and help the students stay on track. One of the things that's one of the key concepts in the lab that I don't have on the slide is that the first principle I tell all the students when they come in here is that you need to stay in school if you want to participate in the lab. In other words, if you get so wrapped up in what you're doing here that your grades are going to start falling by the waysides, then it's time to stop and rethink what you're doing. I do mentorship. I work with the students to find out what they're interested in, who they are, where they're coming from. I spend a lot of time working on filling in knowledge gaps, providing skills and experience, and a little extra training in areas that they don't have the background to do things. Like I do a lot of mechanical engineering things for them. I also promote things like being a constructive experiential approach. And I've got a slide on that that we'll get into in a little bit. So what's involved in this is that if someone comes to me and they say, hey, I saw this really cool thing on YouTube, this video is showing this, that, or the other thing going on, then I sit down with them and I say, well, let's recreate the video. Let's build an experiment that matches what's going on the video. So let's go out and figure out how the video was made. And start exercising your curiosity and start filling in some of the gaps. And then we build it, or we try to build it. We make observations about what's going on, and then sometimes we'll go back and we'll modify the experiment a little bit and try to fill in bits and pieces that were obvious in the video. Sometimes it's an idea, and we'll sit down and build an experiment to do an idea. What I found is that whenever I work with students this way, the knowledge that they gain through doing this process of constructing an experiment, observing, and then going back and reconstructing and redoing the observations is that when they walk out, they're very proud of the information that they've acquired. In other words, they own the information. I've noticed when I teach, I get up in front of a bunch of students and I provide information to them, but I have no guarantee that the students are actually taking ownership of that information. In other words, that information has not become part of their knowledge base. The other thing I try to do in the lab is emphasize that engineering is about doing things. The 30, 40 years that I worked, I don't recall once being paid to sit down and write an equation on a piece of paper. I was always paid to provide results. And the results were always in the form of a working system of some form. So I want to get the students used to the idea that the knowledge that they're acquiring in class is something they can use to build things. It's not just equations, heuristics, and theories. The other thing I try to point out to them is the fact that technology evolves over time. And my favorite story in that area is if someone had come to me when I graduated with my Bachelor's of Science degree in industrial engineering and told me that I was going to be walking around with a computer, a TV, and a phone in my back pocket every day, I'd have told them the science fiction class was 2 doors down and it starts in about an hour. Nowadays, we walk around with something called a cell phone in our back pockets. So it's amazing how things change over time. So I try to point out to them that when you leave school, you're not done learning. So I try to change the Y Labs motto a little bit to get them to start thinking about things in the future by what do new technologies do, how do they do it? And as part of the peace engineering activity, we're trying to get people to become conscious that sometimes using the technology may not be the best thing, that there may be better alternatives. So we start to get people used to the idea of thinking about the consequences of using the technology. So when I do the introductory class with the students, usually I have a bunch of students that'll come up to me who've been working in high school or out of the community college before they came in here, who have projects that they've been working on. They want to continue working on the projects, and so I help them do that. One pair of students came to me, Matt and Noah, and they basically said, hey, look, you know, we've been using these drones and we've been hooking the drones up with sonic sensors. So we'd like to see if we could use them on a Qbot to do a wall following experiment. So we got started on that, and in the process of doing that, they learned LabVIEW on their own. And we also found out that the MyRio didn't have enough processing power to do both the managing the sonic sensors and controlling the robots. So we figured out how to offload the sonic sensor management onto an Arduino. And then they interfaced the Arduino with the LabVIEW and the MyRio. As you can see here in the video, the robot does a fairly decent job of following the walls and skipping over the openings. And I had to clip off the piece of the video where the robot actually comes in and finds the door it's looking for and enters through the door. So Noah and Matt, they got started on another project for me. We started building a robot that homes in on a basically a radio transmitter, which is this device here. And over here is the robot that they built. Basically, we wound up using a pair of differential radio receivers. And the differential receivers were basically using directional antennas. These are the two helical antennas that we were using for direction finding. And we got to joking about the fact that the antennas look like rabbit ears. And we started calling the transmitter the carrot. So the idea was to get the rabbit to chase the carrot. Noah and Matthew got involved in some other activities, and we stopped on the robot radio following. They actually got it to follow the transmitter. There were some quirks, but for the most part. So I started working with another freshman in another class, Jake Gonzalez. And Jake and I started working on doing an improvement to the radio tracking system. Process, we started working with a graduate student named Marius Patriotis, who is downstairs in the antenna lab. And he designed an antenna for us. And Jake and I managed to get the antenna up and going. Jake got a job working over at the National Labs. And so we stopped the project and put it on hold. And I'm looking for another freshman or another student who might be interested in working on radio applications. Nicholas came to me. He's out of high school. He was part of a series of robotics challenges for the Navy. And out of that, he kind of got interested in what we're doing here. I taught him some Simulink, and he proceeded to get into the QDrone project. And you can see in the top video here, or the top illustration, he had the drones actually flying along the outside surface of a sphere. The image on the bottom was another project that he and I started working on, where we were going to try to see if we can get the drones to lift a weight greater than the payload weight on the drones. So he basically designed a system where we would use two drones to lift a weight and control the position of where the weight was relative to the space in the drone cage, or the drone flight space. Again, Nicholas, this guy had a lot of energy, so he wound up working on figuring out how to use the HD2 haptic robot from Quanser to control the flight of a drone. And you can see that here, the upper left-hand corner is Nicholas using the haptic robot interface to actually move the drone around in the drone space. And what's really amazing about this application is the ability for me to do things like outreach with it. So I can bring students into the lab from high school or even from grade school. I've had a couple third grade tours that came through, and being able to use the haptic interface to fly the drones is a big hit, because they don't have to learn how to use the traditional controller device, which takes a little bit of skill and learning to be able to use it properly. And the other neat part about the haptic interface is that Nicholas was able to build in some safety margins, so we could keep the drones from flying into the wall or up into the ceiling or too close to the ground. So some of the senior design projects that we're working on, these come out of the capstone program. I usually sponsor between 2 or 3 projects a year with the senior design activity. Here are some of the previous actions or activities that we've had in the lab. You'll notice we've been doing some things with the QBots initially. And then once I got my drone space built, then I was able to start doing some drone projects. Part of the activities we do in conjunction with the University of Texas, Dallas. So I have some team members from UTD working with some of the people here at UNM. We do other projects besides things with the Quanser QBots and drones. We have an initiative here to build a firefighter communication network system. And we're also expanding that system into getting into doing an augmented vision project this year. I also work with the American University of Dubai. That's what AUD stands for. We're working, initially we were going to do a joint project with them to share the drone space, and they were going to share their unmanned, or the driving, being able to drive the cars. And coronavirus hit, and we wound up having to do a slightly different project. We wound up adapting that project to doing a fly a drone from home. So we came up with an interface for that. All right, so one of the projects that involved the QBots was Evan and Kevin, and they basically came up with, they had three objectives. One was to get the robots to move around in the space without colliding with each other. So they were looking at doing various activities. Here you can see the robots moving around where they're trying not to collide with each other. We had another group of students that worked with the HD2. Those were Zenon and Antonio and Roberto. And they basically put together an interface that allowed someone to drive the QBot using the haptic interface, similar to what Nicholas had done with the drones. The other thing they did was they mounted some IR sensors on the robots, so the robot could detect when it was going to collide with something. And as you can see in the bottom figure here, they set it up so that the robot would shake, or when it stopped, they would generate essentially a pulse into the handle, so the driver would understand that the robot actually had stopped for that reason. The idea of their project was to eventually put that into Unreal Engine, where they would basically be driving the robot around and working across the landscape in Unreal. It turned out that they didn't have time to do the Unreal Engine piece and the level of detail that they wanted to. So that kind of got carried over into the Fly a Drone from Home project. And this is kind of an interesting project. The idea was that the people at home, they could get the Unreal Engine interface on their computer, and then they could basically connect with the lab through the internet. And I would have a lab technician here whose job was to make sure the drones had a working battery, and the communication system was solid, and then the people at home could use the standard gaming controls with the various keys on the keyboard. So it's been kind of interesting, and as we got into doing the project, one of the things we pointed out to the students was that the people probably are going to need to have an offline mode where they can sit down and actually practice flying the drones around. So we built up a menu that says that you can connect with the drone, or you can actually train or learn how to fly the drone offline. As you can see here in the video, the drone's flying, and they're flying the drone in the Unreal interface. It's actually flying over here in the flight space. All the motions of the drone are being reflected back into the Unreal interface. So when the drone does sort of a little bobble or a shift, you can see the bobble or shift going on there. I have another senior design project that's just beginning to get started. What we're going to do is update the QDrone space, or the QDrone interface. The students are interested in doing a obstacle avoidance, like a self-driving car kind of thing, but they want a self-driving robot or drone. So the first thing we're doing right now is experimenting, trying to find out what kind of obstacles we can safely put into the drone space. And once we get the obstacles set up in the drone space where we can actually track the drone once it's moving around the obstacles, we're going to start moving the what the robot detects. We're going to start reflecting that into the Unreal Engine, and we'll start filling in little voxels. And that's kind of what I'm showing over here on the right-hand side with the glowing boxes, is the drone filling in where it thinks the object is. And if they have time, we'll start actually getting into doing the autonomous route planning. Another project that we just got the equipment for is to do a haptic interface for the drones. But in this case, what we're doing is using a device called a Stratus. It's made by a group called Ultraleap. It's basically using a phased array ultrasonic system. And the idea is that they can focus the intensity of the sonic field so you can actually get the feel of key presses while actually touching any keys, so in midair. And that whole system relies on their ability to track hand motions. And we've got our interface to their system figured out. I think Nicholas is almost done writing his Simulink interface, and we're in the process of integrating that with Quark. So hopefully we'll be able to get the hand motions into the Quark, and then from Quark into the drones. And of course, here you can see a series of hand motions. I kind of proposed these initially, and as we get into looking at the way that the Stratus works, we may wind up doing something a little different than what I have here. But for now, this is kind of what we're looking at. Okay, well, I'd like to thank you all for taking the time to listen to what I had to say, and I'd like to take some time to acknowledge the people that have helped with all of this. Dr. Lee, or Tom Lee, and Ramiro Jordan, both have been wonderful people to work with, and I'm grateful for the idea that they introduced me to the YLab idea and gave me the time and the space to build it. I'd like to thank Armin Mulkey. Armin and I were good friends, and his support, friendship, and collaboration over the last 5 or 6 years has been really wonderful. And I think that's one of the nice things about Quanser. You know, the reason I like working with Quanser is that they essentially become partners in what you're doing. And I think of Armin as very definitely a partner of everything that I did. John Penrose, I hope I pronounced his last name properly, but John has been very good working with us. He's their drone person, their drone expert, and he's been wonderful. And I'm very grateful that he's been assisting us. He's the one that provided us the assets for the Unreal Engine. So we're using Quanser's model of the QDrone. I'd like to thank Quanser in general. I know Peter and Paul and all the guys there at Quanser have been very good to us. They've kind of been, in some instances, I have some equipment they donated to us. I'm grateful for that too. And finally, to the electrical engineering and computer engineering department for allocating me space and giving me a small budget so I can actually hire students to work in the lab as mentors for other students, and helping me buy equipment so I can keep the lab going. So with that, I'm going to turn the presentation over to Michael, and we'll get on with the questions and answers.
Thank you so much, Dr. Hamke. That was a great presentation. We really appreciate it. And I think we've got a few questions that came in from the audience here. So the first one is, in your senior design project, what are some of the challenges of keeping that relevant in the YLab?
Oh, that's a real challenge. And part of what we're trying to do is that I am trying to keep track of where the technology or the emphasis of technologies are headed. You know, for example, the self-driving cars is a good example of keeping people's interest in doing the projects. The digital twins actually turned out to be, Fly a Drone from Home project actually turned out to be a really interesting consequence for us, because we have a group of people here on campus that are working with the Sandia National Labs, which is one of the groups that the university works with here in town, where they're actually looking at doing things like using digital twins for various engineering tasks. So I actually had one student that got a job with them, basically leveraging what he learned in his senior design project. So the haptic interface thing that we just bought, I'm looking at that. That's turning out to be quite a interesting area for activity. The group that we bought the sensor from, they just finished doing a project with Lufthansa in Europe, where they're trying to develop a hands-free controls or environment for controlling aircrafts. And I know that they've been looking at using their system to provide hands-free control of things in cars, so that people can kind of concentrate while driving on the road, and they can use their hands to do things like operate the radio or other auxiliary devices in the car.
Thanks. Yeah, it sounds like you're definitely very busy. And so we have another question now. Yeah, early in the presentation, you mentioned that part of the initiatives of the Y Lab was for student retention. So has that helped at all? Have you seen that?
We're at the point now where we're getting up to the first, unfortunately, the answer to that question is you got to wait a little bit. I think we're finally hitting the first 4-year time frame where I've had the lab up and running, and I need to sit down and start gathering some numbers. From what I'm seeing from the students that I'm working with, I think we are making a positive impact on retention, because the students are not getting into classes and finding themselves surprised by some of the things that they're taking. One of the things I do in the 101 class, for example, is that I'll sit down with them, and I also teach the Introduction to Digital Design, Computer Design class. So I borrowed some of the boards, the FPGA boards, from the lab upstairs, and brought them into the classroom, and we actually did an FPGA design. I did 95% of the design, and then I had them finish the last 5%. And they got a chance to find out what that lab was like. I do some work with some Arduinos, where we actually give them a chance to figure out a little bit about programming microcontrollers. I was surprised at the number of students that have never done that before. So the focus in the class has been kind of get them in, get their hands on technologies, and let them experience a little bit of what they're going to wind up doing in their classes, so the classes are not overwhelming when they get asked to do certain things. I hope that answered your question.
Yeah, yeah, definitely. And last one is, now you've worked in a number of companies, you know, I've read your bio, and so what would you say is the importance of creativity and curiosity in an engineering career?
Well, I'll be honest with you. It's the difference between the worker bees and the people that actually get out there and make things happen. Me personally, all the companies I worked for, everybody was paying me to be creative with what I knew. People come into me with problems, and they'll say, hey, you know, how do you do this? And then I'll have to sit down and figure out a way of doing it. I came across that, for example, when I was working with the the military communication systems in the initial part of my life, where people were asking me questions that were, in my opinion, intangibles. They weren't things that you could measure. And then you'd have to sit down and come up with some way of measuring something that would be tangible. A good example of that is we studied the effects of jamming radar systems for air defense arrays. And we basically came down to deciding that a jamming regime was good if the number of pilots returning home in the simulation was better than the number of pilots that didn't. So you got to be creative. If you're not creative, then it's not interesting, at least in my opinion. In the end, when I was working on the little aerial drones for the autonomous robots for Honeywell, there's a lot of creativity involved in trying to sit down and figure out how to solve problems with camera pointing. One of the funny things that we found out was that the people flying the drones from the ground, if we went and we let the cameras control the drone movement while they were looking around, we actually got a better image. So we wound up letting the cameras fly the drones, not the drones flying the cameras, which was kind of an interesting aspect of it as well.
Okay, great. On that note, Dr. Hamke, I'd like to thank you again for the great presentation. Again, we really appreciate it. So, and a big thank you for everybody that attended today. If you want more information, please visit our website at quanser.com or follow our LinkedIn page. And you can find out numerous information about our research validation platforms and any upcoming. And that is it. So I hope everybody has a great day, and thank you all.